Use synthetic division to find the quotient. Specify the quotient and the remainder. If there is no remainder, enter a 0 in the appropriate answer box. In order to use synthetic division, we have to check the divisor, so the denominator here. As long as it's a linear function, and it is, and the leading term coefficient is 1, we're free to use the process of synthetic division. We start off just taking the opposite of the number that's in your divisor, set it against the coefficients of the polynomial and the numerator. So x to the fourth has a coefficient of 1, x cubed has a coefficient of 4, x squared has a coefficient of -5, and then -1, and finally -5. And what I do is generally set aside that last number like this and proceed. So I go about this by bringing the 1 down, multiplying it against the number in the divisor. So 1 times -5 is -5. Then I add this column. So 4 minus 5 is -1. Then -1 times -5 is +5. When I add these two numbers, I get 0. Now, 0 times anything is still 0. Then I bring this next add these two together to get the next value, which is -1. -1 times -5 is +5. And when I add these two together, I get a remainder of 0. So that's how I interpret this. This is my remainder. This next term is a constant term in a polynomial. This one is multiplied by x, and the rest of these are just increasing powers of x. So the result here is the polynomial x cubed minus x squared. We can skip the plus x because it would be plus 0x, then -1. Then the remainder you could put in as 0 over the denominator, the original denominator, x plus 5. But because 0 divided by anything is just 0, we can actually leave that off and just say that the result is this remaining polynomial.